the DC output voltage of a half wave rectifier. How to calculate the DC output voltage of a half wave rectifier. In this video, I will demonstrate how to calculate the DC output voltage of a half wave rectifier. Okay, the steps in calculating DC output voltage of a half wave rectifier. Here on the screen we have a half wave rectifier circuit. The rectifier is fed by a 120 volts AC source through a 10-to-1 step down transformer. Okay, so here we bring 120 AC volts. So the input is 120 volts AC. Okay, good. Now this voltage is stepped down to reduce the voltage by a 10-to-1 transformer. So the voltage, so the first step is to calculate the AC output voltage from the transformer, hence the AC input voltage into the rectifier. Because if you can calculate the voltage, once you know the voltage from the transformer, that is the same voltage into the rectifier. So we do that by dividing the input voltage by 10. So this would be 120 volts divided by 10 equals to 12 volts AC. So that's the voltage out of the transformer. Next step, step number 2, calculate the peak voltage into the rectifier. Now, the 12 volts AC is what is called an RMS value. Okay, that's an RMS value, which is a kind of an average value. So what we want is to see the actual peak voltage, right? Remember, from a previous video, the input waveform would be that, and the output waveform would be a pulsating DC. So what we want to find out is that peak voltage. We want to find the peak voltage. Peak voltage. Whenever you are given the AC voltage, it is assumed that that is the RMS voltage. So this is actually RMS voltage. Now to convert the RMS voltage to the peak voltage, so the peak voltage is equals to the RMS divided by 0.707. Okay, so in this case it would be the voltage out is 12 volts, so the peak voltage V peak would be 12 divided by 0.707, and that equals to 16.97. 16.97 volts. Okay, right. So the actual voltage, the peak voltage, so the V peak in, the peak in is actually 16.97 volts. Next, we need to determine the voltage peak out. Now, for a silicon diode, we assume it's a silicon diode, there will be a voltage drop of 0.7 volts. So V peak out, will be, so V peak out equals V peak in minus 0.7 volts. Okay, so we have 16.97 minus 0.7, and that gives 16.27 volts, which equals 16.27 volts. That's the voltage out here. So that's 16.27 volts peak. And that is the same voltage across the load. All right. Now that is a pulsating voltage, right? That's a pulsated voltage. Now, if we were to use a multimeter to measure this volts, we would, in the DC range, we would get an average volts, which would be something like an average like that. And that average voltage happens to be, so V DC is equals to V peak divided by pi, right? So in this case, it is now 16.27 volts divided by pi. 16.27 divided by pi equals to 5.2 volts, for 5.18 volts. 5.18 volts. Okay, so that 5.18 volts would be the voltage you would measure if you took a multimeter on the DC voltage range and measured across the load. So starting from 120 volts in, input was 120 volts in, it will step down to 12 volts out of the transformer. Then that 12 volts RMS equated to 16.97 volts peak. Then out of the diode, there was a voltage drop of 0.7 volts. So then you get 60.27 volts peak out of the diode, which is that same voltage across the load. And then to find the DC voltage, we simply divided 16.27 volts by pi, and we got an answer of 5.18 volts.